Okay, welcome everyone to this session. I will present this work I've been doing with, this exploration I've been doing with Matlab Apps and Matlab Web Apps. We'll see what they are and so on. And what facilities we have in LaCàN for doing this in a very easy way. I will be standing, presenting, and then I will be sitting with some Matlab code. So I will be combining these two things. So first of all, what are Matlab apps? So here you have an example. You have a laptop, go into this website, or if you have a phone, also with the phones, you can scan one of these two QR codes. Now, if you're in the laptop or smartphone, you have to connect to any UPC network, EduROM or LaCàN Wi-Fi, and so on. And also, if you are in your phone, you have to enable desktop mode in your web browser. So let's just scan the first one. Let me show you, as an example, what you should see. This is an example of an app for continuum mechanics. So you access here, and you as a user, you can change what is the domain size. In reference configuration, you can define a deformation map, and it will plot right away some deformation modes. As a shortcut, we have some examples you can load. For instance, uniform shear. This would show the reference configuration. The current configuration according to the deformation map you have inputted. And then you can visualize value of the Jacobian, value of different measures. For instance, the right deformation tensor with the different components. You can visualize that in the reference configuration or the deformed configuration.
Can you try with a non-uniform?
Yes, that's what for instance, Euler-Bernoulli cantilever, for instance. You have reference configuration, current configuration. This is the deformation map according to the hypothesis of Euler-Bernoulli beams in small deformations. So for instance, you might see the XX component of the infinitesimal strain tensor. Red is positive, blue is negative, tension, compression. You might compare that, for instance, with the green Lagrange strain tensor in large deformations, which is different, it's all positive. Okay, you can play around with this tool, and as soon as you update this deformation map, it will plot a different deformation pattern. Good. This is one example. The second QR code is on the differential operators app, another example in which you can choose a differential operator, again choose the domain limits, and input some scalar field. X squared plus y squared. And this would plot right away the scalar function you are plotting in one side, and in the other side, a arrow field corresponding to the gradient of the plot you have, of the function you're computing, right? Also, another feature is you can turn this on. You want to see the output at a specific point. So you can drag this point over the domain, and here it will visualize at this specific point what is the result. Or you can just input a value directly. It will update. Just two examples of apps that may be used in academia, specifically for teaching, when you're teaching differential operators and so on. I find this very useful. So what are Matlab apps? They are self-contained Matlab programs with a user-friendly interface so that we can do Matlab operations without touching any code, right? And all the operations required, all the inputs and all the outputs, in this case, the value of the function, the domain limits, and the outputs, the visualization, is done within the app. I don't have to go to the command line of Matlab and write anything. All is done interactively within the app. When to use Matlab apps? Again, to produce results without any code. And I find it specifically useful for hiding code to the users. For instance, in teaching. In teaching, you might want to, we have an app for Newton-Raphson in 1D, for Newton's method. So you can visualize how different iterations work to the user without coding, without showing the code of Newton, without sharing the code of Matlab. Why? Maybe you want to give a session in which you want the students to code that, but you want first them to have a sense of what this code should do. So they can visualize the output of the code without showing the code because you want them to produce this code. Also, just to illustrate what a differential operator is, what the gradient is, you can use that as a teacher in class, or students can use that in class or in homework as well. And I also find it useful to produce nice figures for exams or for homeworks in 2 clicks instead of opening Matlab, right? Also for research, this is useful. And we have some example here in LaCàN to show specifically, also for repeated action, if you have some pre-process, post-process operation, you can open a Matlab app and do it. It's easier than with code, perhaps. Also for showing a lot of, when you have a lot of results for some simulations, maybe you can do a Matlab app to visualize that for a conference. And this is exactly what Fabiola did in 2022. The paper was published, but also in her PhD thesis. He was doing these simulations of optimization of car components, depending on different parameters, and depending on this width of those different components or the strength and so on, you might have some output of interest that you optimize. I don't know exactly the details of that. But basically, you have a Pareto front, which gives you the different optimal points. So in order to show how this optimal solution changes in the Pareto front by changing the input parameters, you might use an app. Instead of showing a video, or instead of showing 3, 4, 5, 6 figures, static figures, you might go to the Congress, use an app, and maybe in the question, right, someone in the audience asks you, what if you put this parameter there and this there, and you do this in real time and show what is the result. Maybe you can do that to output our results. So also for research, this is useful.
So, would you be computing in real time or retrieving stored information in real time?
You will want to retrieve whatever you want, but I would retrieve stored information, obviously. Yes.
Okay.
If you want to show your code is fast enough for real-time applications and you want to show that, you can do that and say, this is computed in real time. If you want to present results, I would just load data, store data, and visualize it. Yeah.
Okay.
Where do we find Matlab apps? Matlab apps are already there in Matlab. In the apps tab of Matlab, what is it? If you go to Matlab, here you have an apps tab. So all of these are Matlab apps. Maybe you know the PDE tool or the CFT, the curve fitting toolbox. Some of the apps that are already there in Matlab. You can already use that if this is what you want. You don't need to create your own app. Okay. Second, you can go to the MathWorks file exchange, which is this platform Matlab has to share Matlab code between users, and maybe some other user of Matlab already implemented that. So, again, if you go to Matlab, where is Matlab? Right here. If you go to Home and then Add-ons, Get Add-ons, you have a list of Matlab files that are there in the Matlab community. Some of them are Matlab apps. So if you want to design an app for Fourier series, maybe some other Matlab user has already done that, and you can use that right away. Otherwise, the last option listed in here is to create your own app, which we will see also today. Now, why do we use Matlab apps? We always also have GeoGebra and other bunch of alternatives. I will not do a comparison. The thing is, I did not try any of them. Not even GeoGebra, I did not try. Some of you did, so I want to discuss after this talk or some other day to compare about this and Matlab apps. But the thing is, I found Matlab apps very, very useful if you already have a Matlab code that you're using in class. It's very easy to transform this code to a Matlab app. This is first. Then you can do almost everything you can do with Matlab. You can put that into a Matlab app. 99% of the things you can do in Matlab, you can put that into a Matlab app. And designing a new app is very easy, as you will see, I will show. And it's easy also to share as a web URL with the server we have in LaCàN. So those are the advantages that are there. It also works in smartphones. It only works, the thing is, it works. So this is not a problem of Matlab apps. It's a limitation of the server we have for this in LaCàN. It should work with 30 people at the same time. So we will check that. It's not a limitation of Matlab apps per se. So how to create a Matlab app? This is what I want to show you next from a pre-existing code. Where is it? All right, it's there. Let's say we have already a Matlab function called Fourier approximation. This is a very simple example in which you choose one of three examples, example 1, 2, and 3, which are different x, y points. We have 6 points. And we do a spline interpolation of it. This is the input data, example 1, example 2, or example 3. And we want to approximate this curve with Fourier modes, with 1, 2, or 3 modes, or whatever modes. So once the data is picked, we compute the amplitude of the modes, we have the solution, and then we plot the solution, basically. This is a Matlab code that is working. So what if I call Fourier approximation of example number 1 with 1 mode? It works. Let's see if it works. It will plot the figure. This blue data is data of example number 1. This is the curve we want to approximate, and with just one Fourier zero mode and then one oscillation mode, this is the best approximation we have. If we use 2 modes, we have a better approximation, and so on, right? If we change the example and we pick the second example, say 1 mode, the input data is different, this blue curve, and with 1 Fourier mode, this is the best we can do, with 2 modes, and so on. So this is a functional Matlab code. How do we turn this into a Matlab app? You can click here in New, Script, or Function, or more things. One of the things is App. So you can create a new app right away. And this new interface of Matlab called App Designer is open, which has different panels. This central one is your app. This is the layout of your app. Right here. So this is right away what the user will see. What do we want here? We want some access. You just drag a component here in the left, and you place it wherever you want. And then we want the user to be able to choose one example. So we might pick a drop-down list. We can double-click here. This is example. You can also, this is example number 1, number 2, number 3. Those are the 3 strings we have. Fine. And we also want the user to choose the number of modes. 1 mode, 2 modes, 3 modes. So you can do that with a slider, but the slider would give you a continuous set of numbers. Where is it? The spinner, if I see it right here, spinner. So we can put here number of modes. Okay, you can rearrange that as you prefer. This is just an example, right? Then you save this app. The name of the file is whatever you want. The extension is mlapp. Scripts and functions are .m, apps are .mlapp. Okay, and I save it here in this folder. Fine. Okay, it's saved now. Now you can run this code and see what it does. You have this window, which is the app, and that's it. You have a drop-down list in which you can select different examples, and you can increase or decrease the number of modes. But of course, nothing happens yet. You have to connect this with the code you already have, right? This is just the interface, let's say. By the way, for each component you have dragged from the component library, you can click here. And here on the right, you have two things. You have all the list of components that are in the app. I have the UI access. This is the access I have here. This thing here is the app.numberofmodes spinner. Okay, this is the name of this component. And this component is named example dropdown. So for each component, you have here below different properties. So if you want to change the X label in here, you can click here and change. Title, whatever. Solution. You can modify different properties here. The font size, the font name, and so on. All the typical things you can customize in Matlab are there for each component. Okay, one of the things you can also do for components besides all these properties are assigning callbacks. Callbacks are functions assigned to different components. So whenever the user comes here and changes this, I want some function of Matlab to be run. This is what a callback is. So we go to this example drop-down component. We go to the callbacks here, and you can assign that different functions for different events. Whenever the user changes the value, some function will be run if I create a callback for this. Whenever the user opens the drop-down, you could also assign a function, or whenever the user clicks in it. We want to run something whenever the user changes the value, has already changed the value. So we go here and we add this callback here. And this switches the view to the code view. Before we were in the design view where you see the interface. You can go now to the code view and you see all the code that is generated that corresponds to this app. An app is an instance of a Matlab class, which is app. If you know about Matlab classes, this is the syntax for any class, and apps are classes. Now, most of the lines you cannot change, you cannot modify. You can only modify lines for those functions that you create on purpose and so on. So we have here this function which has a default name, which is callback means function assigned to a component. Whenever a component changes the value, whenever a component opens, and so on. But it's just a Matlab function. So here we have whatever the value the user chose. What do we want to do with this value? This is the example, right? The value of the example drop-down component. So we want to run the function Fourier approximation we were running before with the example. And then with another parameter we still don't have, which is the number of modes. Fine. Now, what is this number of modes? Is the value of the other component. If I switch to the design view and I click on this component, which is called number of modes spinner, one of the properties is the value. So it's a very similar syntax. For the example dropdown, dot value is the value the user chose. So the same thing here for the component named number of modes spinner is the value, and this is number of modes. So what does this function do? Whenever the user changes the value of the dropdown, chooses one example, it takes this value the user has already chosen. It also takes the value of the spinner, which has the number of modes, and it calls this function. That's it. We save it, and we can already run this thing. Of course, we assign the callback a function to this component, but not this one. So if I change this, nothing will change. There is no function assigned to this, but it is attached to this. So whenever you choose an example, this Fourier approximation example will be run. And nothing is plotted here. Instead, it created a figure. Yes. No. So we have two functions. The Fourier one is not. So you can have functions defined inside the app, or you can use pre-existing functions defined in files. These functions we are referring to is exactly the same function here, .m, we have here. We have the .mlapp file. It's in the same folder, yes. We have the mlapp file, and here we have this function we are calling, we can also use. We can right away use files and functions specifically, which are defined in files. If you want, again, you have here also some functions tab, and you can create a new function. You can copy paste. There's no point of doing that if it's already there in a function. But what did this callback function do? Take the two values, and it ran the Fourier approximation code, but it plotted it in a different figure. Of course, we did not specify that we want to plot in this component. We just created plot. And this is typically what you do in Matlab. You take some data and you say plot x, y, and there's no figure, there's no axis. If there's no figure and no axis, it creates a new one. Otherwise, by default, it plots on the previous one and deletes whatever you have if you don't have hold on and so on, right? So typically, you don't specify where to plot things. Now we want to specify. We want to plot in this axis here. You could have another figure, two axes, and plot different things in different axes at the same time. So you have to specify always in Matlab apps where to plot. The name of this axis is app.ue axis. So what can you do? Simplest thing you can do is to add a third input to this function, which is which axis am I plotting in? And for each function for plotting, all of them admit a first optional argument, which is which axis you want to plot. This is already there in plot function in Matlab, in while in function in Matlab, and so on. So one of the important things is to specify where you want to plot. This is the only modification we have to do. And this is the third argument of this Fourier approximation function. So we go to the Matlab app. We can go to the code view, to the list of callbacks. We have this callback right here. And we specify we want to plot in some axes, which are the axes we defined at app.ue axis. You can change the name of the components here in this list if you want, but this is enough. Now you can run this again, and it should work as expected. Still, there is no callback to this component, but once the user selects one value, the plot is there. Now I want some different input data. Well, that's the input data. But this feature still doesn't work. So what do we want to do? Basically, we want to assign the same callback. Whenever a user changes one or the other, we want to take the two values and plot in the same axis. So you can go to the design view, this component callback. It still has no callback. You can create a new one, or you can select one that is already existing there. We want the same callback that we had for the previous one. Now I run it, and it will work as expected. And that's it. And one of the cool things in the Matlab Designer in the code view is that you can debug in the same way as Matlab code. Now I run this figure opens. Now the user changes the example, and we are here. We are in the debug mode. We have the value of this variable example 2. This variable is not defined. Once I step, I have number mode is 0, and so on. You can debug in the same way as Matlab code. And now they should work as expected. That's it. And the app is ready. That's it. We don't have to do anything else. The app is this .mlapp file, which is there in your computer. This one I created. This is the Matlab app. That's it. I think it's pretty easy. The only thing to remember is, all right, right here. The only thing to remember is that you always have to specify in which axis you want to plot which things. And that's it. Besides that, it's just dragging components to the canvas, adjusting the properties, changing the name, changing the label, changing the font, and so on. Assign callbacks to those components so they do things. And if you have to create a new callback, then you define it in this code view panel. That's it. Also, you can define variables, Matlab variables, inside this app if you need those variables. If you need different functions to interact with different values, you could also do that.
I need one question. See, when you call the function, you were defining the case as a text. No?
Yes.
Codony. Why in your app this is assumed?
Which type of the thing is that the drop-down component I put defines options as strings directly. When I put example 1, 2, 3, those are strings. Drop-down is text because that's the default behavior of that component in Matlab. If you want, you can change string to numbers, but this is why. This is why. And then the other component which uses the number of modes, by default, those are numbers. Spinner is not, the objects in there are numbers. This is the variable type that different components have already. I knew it was strings, so the function was prepared for strings. Otherwise, you just convert. So as I was saying, you can define also variables which are called properties. If you want a variable x equal 5 to be permanently living while the app is open, you can define it as app.x equal 5 as a property. This is called, variables inside apps are called properties. That's it. How do we share Matlab apps? Now the app is ready, how do we share that? We have 4 ways. You can share Matlab files directly, package the app, create standalone desktop application, or deploy a web app. Let's go one by one. First one is sharing Matlab files directly. So I give you the MLApp file, and in order for this to work, I also send you this Fourier approximation function, because otherwise it will not work. I have to make sure I send you all the files. This is useful only if you're sharing this with someone who will modify something to implement some new feature there. Otherwise, it's not so convenient. It's not the most convenient way. I would not share this with students. So they have to go in their laptop, configure Matlab path, run it properly, and so on. I would not do that, just for developers. Second option is package your app. And we will see this later on, if I can show this to you. But the thing is, you can create a file out of this MLApp file called MLApp install file. This is just a file that you give to someone so that they can install Matlab apps in Matlab directly. So they appear in the Matlab app. Same as the curve fitting toolbox, same as the PDE tool. Another one will be Fourier approximation, if they double click this and install the app by doing this. So in this case, the user needs Matlab. This is good to share with other Matlab users, for instance, to the MathWorks file exchange. Another way is create a standalone desktop application. You can create an exe file. So the user double clicks and they can install it in Windows or equivalent for Linux and Mac, and they can run. Once the app is installed, it's a program in the computer, and they can run. And this requires no Matlab license. So the user who installs this doesn't need to pay for Matlab. But it requires installing Matlab runtime. So first time they install this app, if Matlab runtime is not installed in the computer, it will also install. So it's Matlab runtime is just the machinery you need to run Matlab code, but it's not requiring a Matlab license. You cannot code with that. So this is good for offline usage. I go into my laptop, I'm not connected anywhere, I can run this app offline in my computer. The last one is deploying a web app. When I say this presentation is for Matlab Web Apps, this presentation is for Matlab Apps. If you put it online, it's a web app. That's the only difference. So for this, you need to create a CTF file and just place it in a specific folder in a Matlab server. And that's what we will see also now. And this is for online usage. You access through an URL, as some of you did in the beginning, and it works. In not too many sessions, but it works. And the thing is, it also works in smartphones, but you need to turn on this option in the web browser, desktop mode, modo escritorio. You have to turn this on. Otherwise, it will work. So now, for this last option, we have a server in LaCàN supported by Ignacy, which in principle allows 32 sessions at the same time. I will verify this. Otherwise, we will upgrade it so that you can do this very easily. So if you go to this website, let's see if I can share this. Well, it's this website here. This is the website I was telling to you, which reflects all the apps, all the Matlab web apps that are there in the LaCàN server. All of them are created by me for now. but some of you are also using in different classes, so I'm happy about it. So we have the continuum mechanics we have seen. We have these differential operators one. We have some others for parametric curves, parametric surfaces that I use in my courses, or you have these different apps for route finding. So you access this website, you click on any of those, or you right away share the URL for a specific one, and you can play around with this app right away. In Matlab, how do we do that? Do I have here? All right. Here I have a backup app of this application. Let me change this. This should be the final version of the app. Let's open it again. Now look, yes, let's see. Let's open Matlab Designer again. All these different options, the first one is just sharing files. That's it. The other three options you will see right now. They are very straightforward. It's just 2 clicks for each of them. Let's say I have this application. This is not the one we created. It's one I created yesterday for backup for this, but it's basically the same thing with different title and so on. How do we share apps? You click here in the App Designer interface, the one we have seen before with design view, column view, and so on. Here you have an option which is for sharing the app. If you share this as a Matlab app, it's 1 click or maybe 2 clicks. A new window will open with some options and so on. We don't care so much. You click on package, and once it runs all the testing and so on, you will be able to click this button, and this will create this file. Apart from some auxiliary files you don't care about, it will create this ML app install file. So if you double click on this ML app install file, it will install the app as in this tab here. So this is good for sharing with other Matlab users. Instead of this, if you do create web app, it will do something similar. And besides a lot of auxiliary files you don't care about, you will get this .ctf file. This is the file you just have to place in a specific folder in the LaCàN server. Once you place it in a specific folder, it shows up in the website. That's it. And the last option for sharing the app is creating an exe file, standalone. So this is the same thing. You click in here, it will create some file like this, my app installer.exe. You share this, and someone can double click here and install this app as a program in the computer. Those are the three different ways. Let's go back to the presentation. So if you want to deploy a web app in the server we have in LaCàN, you have to follow those steps. You have to access the LaCàN server, so you have to request access to Ignacy, then you access the server, and then you just create this CTF file, share Matlab Web App, and create the CTF file within the server. This is important because the version of the server of Matlab, the Matlab version of the server should be the same as the Matlab version which this CTF file was created. So you copy-paste files there, and you create the CTF file with the same Matlab version in the server. And then the CTF file, you place it in the proper place in the server, okay? That's the only thing. Let me try to show you how this works in the server. All right, this is a remote connection to the Matlab server. So the only thing you have to do is open Matlab in here. Here I have the same files. Now if you share, you click on the share panel and select Matlab Web App, you have this file. And now you copy paste this file in the proper Matlab folder of the server. Here we have the Matlab Web App server application installed. I open the folder. This is just one folder in the computer, and I leave the apps here. I have three folders: continuum mechanics with one app, route finding with some other apps, and vector calculus with some other apps. This is exactly what we were seeing here: continuum mechanics, route finding, and vector calculus. So if you drop a new app there, it will right away appear here, and it will be available. It will be assigned a URL, and you can right away share this with whoever. All right. So this is basically it, unless you have some questions. Feel free to use the apps that are already there in the server. If you have some trouble or not, let me know. Let me know if you use those as today, as if we detect some problems, we can improve that. For instance, the number of concurrent sessions is perhaps still configured to 4, so we have to increase that. Otherwise, if it works and it works fine, also let me know. I'm happy to know you're using the apps I develop. And if you want to create a new app, or you have a new idea for a new app, or you want to create it on your own, I'm happy to help also. It's very fun for me designing these apps. So feel free to contact me for these things. And that's it. Thank you for coming. And if you have any questions, I'll be glad to answer.
Which is a limitation for 432. Does it create a big demand on the server? You have 100.
Yes, that's the issue. The thing is, if 4 of you connect to the server, it's like going to the LaCàN computer and opening Matlab 4 times. So your computer needs as many resources as needed for supporting this. So if your application is also does a lot of heavy computations, solves finite element problems and so on, also you need more memory, more resources. If the app is very small, does a few things, also you need few resources. Also, in the current server, we don't have a GPU. So all the graphics are done in the CPU. This also slows down. A lot of improvements can be done in the server itself, also in the server configuration. I think the configuration is now 32, but maybe the limitation is that there's no more RAM allocatable for so many sessions, so that's why it cuts off. But yes, so it's the same as if I go to the Matlab server, which is a computer in LaCàN, and I open Matlab as many times for each of you that are connecting.
Number of licenses, this is not a limitation.
I don't know. Now it's set to 32 if the resources of the server were large enough. Maybe that's the maximum for the Matlab license. I don't know. No more questions, no more comments?
Yes.
So the one you've used the class already?
Yes.
And you used the web app.
Yes.
The web app. And you didn't have the issue. Sorry, I'm a bit lost with this recent discussion about 4 and 32. You didn't face these issues about.
I mostly use it just to illustrate concepts, gradient, and so on. Me only as a teacher. Because I only recently discovered that this can be run in smartphones. I thought it was not possible. I always tell students, you can, if you have a laptop or a tablet, you can run this at the same time and play around. They typically don't have a laptop or don't care or don't do it. So I never faced this problem. Or if I connect first and they cannot connect and don't work and they don't tell me, I never faced this issue. Then Koke used that in a class with 20 people or so. And there are some, okay, make groups of 4 people in a computer and play around. Yeah, we didn't know about this limitation. But this is something that is more and more people uses, and we want to invest resources on this so the server is more powerful and so on, we can do. It's up to us. I'm also curious if someone used GeoGebra. I know some of you do, so we can discuss some later on, probably.
You said that it's important to match the version of the code with the version of the server.
Yes.
What is the version of the server that we should use if we want to do this?
The current server, does this work? Is 23A. The thing is, you can create the ML app file. You can create the app with whichever Matlab version. And then once you copy paste the files into the computer and open it with a different Matlab version, it will automatically translate versions. And then with that Matlab version, you create the CTF file. Only the last step of creating CTF is required to match the version. Otherwise, different versions have maybe some other new component is available, which is not there in 2023. If you use 2024, these things. Yeah. Another option is go to the server right away and start creating the app there. It's slower. It's a remote connection and so on, but you can also do that. No more questions, comments? Okay, thanks for coming.